Pelco is a unique company, we like to think, in our offering within this industry. We started off with a legacy product. A lot of people familiarize Pelco with what's called the AstroBrack. The AstroBrack is kind of what we consider our legacy product. 40 years ago when the company was founded, it was a concept at the time, and its purpose is to take a traffic signal and have a specific method for mounting it to a mast arm or a pole. Well, over the years, our product catalog has gone from a couple pages worth of signal mounting hardware to really a mounting solution for anything you would see at an intersection, along with a variety of other products. You know, we do back plates, push buttons, PED bases and poles. We do some traffic mast arm and poles. So our catalog over the years has grown to several inches thick, and that's kind of become our identity, is a little bit of everything. With the buzzwords at these shows being ITS and everything technology driven, you know, everybody wants to be able to mine data from the intersection, do all this, achieve all these different things through technology, but all those things have to be mounted as well. And so whether it's a camera or piece of detection equipment or a radio or some sort of communications device or whatever it is, we like to think we have a mounting solution for any of those scenarios. Again, our most popular one, or what we refer to as our legacy product, is the AstroBrack. It's grown, it's evolved over the years. The design has changed. We've sold over 1 million of these things since the company's been open. So, you know, there's no shortage of voice of customer feedback, and we like to listen to those voices. So it's evolved over the years. We're pretty proud of this version today. This is used for really anything that a signal would be the most common, but anything that has you know, a gusseted tube or has the right components. You know, cameras are put on those gusseted tubes, all kinds of other things, not just signals. But this is designed to take you know, one of those tubes, and we're proud of this because it has all the same size hardware now. So you only need one tool to install it. But this is like our most common application. This is a similar model as well, similar design in that it's all the same size hardware. You only need one tool to install it. But this is designed to take, you know, this is a telspar tubing. It's used to mount signs. Also used heavily in school zone flasher applications. We've got some other brackets that are used for larger wire capacities, larger wiring, larger tubes, you know, if they have a 2-inch tube, if it's a real heavy piece of equipment. So we have larger versions of that. We have an articulating orbital mount that's used to, you know, take a radio and point it in a certain direction from intersection to intersection. And then, you know, probably 30 other pages in our catalog of mounting solutions. We have framework, which is taking certain length of piping and elbows to use it to adhere it directly to a side of pole. And we work closely with all of the school beaconing manufacturers, and we have good relationships with other manufacturers in the industry who take our components, package it with their system to allow the end user to have a full turnkey, you know, package at the end of the day. We don't make a lot of the large mast arm and poles. We do for some local customers close to home at Pelco. But what we really make a lot of are the poles that hold the pedestrian signal and the pedestrian push button. You know, those are separate from usually the mast arm and the pole to get them closer to the crosswalk for pedestrians to have access to. And even now with, you know, APS buttons, visually impaired people helping guide the, you know, the vulnerable pedestrians across the intersection. So those poles that are used to get those closer to the crosswalk with those smaller bases, we do make a lot of those. So this is a really neat product. Pelco's had this in the market now for a little over a year, but again, I mentioned voice of customer and various other sources of input that we get. For this one in particular, it didn't start through a voice of customer. It started in a lab in Florida at the Wall of Wind, where we were testing the integrity of some span wire components. And as the signal was, you know, the wind speed was increasing and the signal's galloping around everywhere, the hardware held on, but the backplate flew off. And when the backplate flew off, obviously it decreased the surface area of the signal, and the galloping on the signal decreased severely as well. So our engineers went back to the drawing board, and they came up with a unique option for a backplate that would decrease the surface area of the signal in high wind load. And so through the use of this flexible material that we've designed and engineered, we've been able to achieve the reduction of many load applications where backplates are required but haven't been able to be considered due to the added wind load. So the thought, the design is for the flexibility to begin somewhere around 30-mile-an-hour wind. And like I said, we've been able to decrease galloping on the mast arm from those wind load reductions. We've been able to decrease the load on the hardware for the signal. I mean, everything takes a beating when those wind loads kick up. And when you have, you know, a large number of signals hanging from that arm, if you can decrease that load slightly at all, there's a huge benefit there.